Hello developers, let's start developing. So today on the table we have the 6th day of Advent of Code 2023. At the first read, this seems like a relatively easy task since we have basically two lines of input and we just need to do some calculations with them. Basically we need to raise toy boats and we have 7 seconds. And the algorithm for racing the toy boat is you press a button, you lift your finger, and then the boat speeds off with the speed of how many seconds you hold the button. So if you hold it for 1 second, it goes off with the speed of 1 meter per second. If you hold it for 5 seconds, it goes off with a speed of 5 meters per second. So our goal is to get more than 9 meters. And actually we need to count in how many ways that can happen. Seems like a simple thing, but anyway, we can start. Already start. So how will our input look like? Seems like it will be a simple, not a race, this will be races. Actually, what not have a race, which has a time, which is a number, and a record, which is a number, and then have our input as a race array. Or as Angular done is doing, we might want to define a type called races. So instead of a string array, we're gonna have a race array. And now we will need to basically read the lines. And there will be two lines. Actually, we can already say that this is the time line and the distances lines, records, because those are the record distances so far. So we have the times, we have the records, and now we can just map them. You can see we have a lot of spaces between the characters, but we can just run a split. We can even do a regex, but who cares? Yeah, let's do that since we can do we can basically do, there are multiple ways to do this, but I like the cleaner ones better because we can say this thing we can just split on a space, on a space, and then we have these things, and then we can filter uh, word, filter out all the falsy ones, and then map it to a parsing. What do you mean 7 doesn't parses? It definitely should, and 15 shouldn't parse as one. Let's write it out. Parsing the word on in Canvas. Yeah, now it's better, and I want to filter it once more. So we have word, and we want to get the ones that are not nuns to basically, no, it's not now, it's a digit, it's a number. And we just get the values. But I want to do it a bit more complicated. So we have the start of the string, and then we have time. So we have that, we have a bunch of strings, of spaces, and then we have everything else. and then it ends. So this will just get us the numbers, and then we can avoid all that non-management. Oh, sorry. So we can say times dot match what was the story. I don't need a G. And then we have that. And the R match will be the same thing, only it goofed up on the logic. This is called distance. So now will assume that if this doesn't work, then it doesn't work. But we can assume that the first match, the first group that we match, has a equal number of numbers. So we can say for some more variables. The values is times t match of 1. We're gonna split it not on that, but on that, and we're gonna filter all the spaces, all the empty strings. And of course, this needs to be after this. We're gonna have the record values as well. And then we can, and this is an array of numbers now. So we can have a for loop that says t values this is the t, and the r values also get it, and then we will have arrays, array object, and we just say result dot push, the time is t, the record is r. Or we can just rename these, since we actually didn't use those variables, and then we can just say use the time and the record, and that's it, and return the result. First of all, as always, let's see if our races are actually correct. Start the 6th day. 7, 9, 15, 40, 30, 200. So where were you? You're here. 7, 9, 15, 40, 30, 200. Seems that we have the date. So now for each of the races, since the numbers are relatively small, and I have a feeling that we are reading something wrong and it will be different in part 2, but for the first part, basically what we need to do, for of race of input, not raise the type, raise a variable, and we can actually even deconstruct this. I need to say time and record. Do it. Now, let's not do it because we're going to have a function that's called get times, and it will actually take a race value, and we will deconstruct it here. So it will be time and the record. What's wrong? Yeah, we didn't define it as a function. Yeah, we're not gonna do it like this. This for loop is totally wrong, but what we're gonna say? Well, from 0 time up to time, we're gonna calculate the distance it will travel. Well, the distance will be not this, not index times records, but it will take index time to actually push the button, so the speed at the release of the button will be index. So we're moving with an index speed times how many seconds we're running, time minus index time seconds. So if we release at time signature 0, we're traveling for 9 seconds with a speed of 0, so it's not much of traveling. But if we release at index 1, again, and if we release at index time, then we are traveling 0 seconds with the speed of time. So we don't even need this because the index will be identical, so we just push the distance. So we will get all the possible distances for this and then return the result. This could have been a map or something like that, but okay. So all the distances will be, oh no, this is not get times, this is get distances then. I have a definite feeling that since this is basically a square equation, we can solve it, we can optimize it, we can analytically get the values, but this works if the higher number is 30, so we can here. And even in the big input, from what I've seen, the highest number is 86. Works. So we're going to brute force it using for loops and things. So this kind of approach is usually referred to as for loop goes brrrr. So we get the distances. We are getting all the distances for that race. And you can see that we're not even using the record. Yeah, we're just using the time, which means that we don't need to have a race, we can just have a number, which means that the construction was properly done here. So we got the distances for the time, and now we just need to get the number, the ones that are bigger than the record. We're going to use strictly bigger because I think it's mentioned in the explicitly in the test that we need to go further, not further or equal, but further than the record holder. And so we need to find out how many ways we can do that. So let's just console log those numbers. Four, 8, and 9, and we were supposed to get 4, 8, and 9. We just multiply those. So no const, let total equals 1. We're multiplying, so don't start with 0. And we just need to say total is times equals bigger length, and we're returning the total. Not input the total, just regular total, and let's see if this thing works. We should get 289. We're gonna get 289 if I know how to. 288 if I know how to multiply, and I read it wrong. So now we're gonna replace that input with a much more complicated input. It doesn't feel much more complicated, to be honest. And let's see if we get some other number, bigger number most likely. We got it. And let's see if we are done with part 1. We are. So, part 2. Let's see what we got wrong. Piece of paper was just had very bad kerning. That's really only one race. Ignore the spaces between the numbers. Aha. Yeah, now we're talking. The race lasts for this, and the record distance is this. Okay. So instead of this number, now the difference in the input is kind of significant. So for part 2, it's not this number we're using, it's this number we're using. And that's 50 million. As I was saying, it's not a problem to run something from 1 to 30, but until 50 million, who knows? Well, now we kind of screwed ourselves with the parsing because we have the races and we have the records, so this is not the best way to actually do the input, but well, it already worked for part 2, so now we're gonna need to go back. So we're in a situation when we're gonna make the eggs from the omelette. So, so the actual time will be input.map, the time. I'll go back to this. So we're extracted the time and then we're gonna reduce. Actually, I'm gonna use a bit of JavaScript. Yeah. In some more proper languages, this might be hard, but in JavaScript, there is not a lot of difference between a number and a string. So if we have the array 1, 2, 13, 4, we can just say join this with a nothing in between. It will give me the string, and I don't even have to parse it. If I add a plus to this, I get it as a number. Hmm. Seems weird, but it might work. Not the best or fastest way to convert strings to integers, but it might work. And of course, we forgot -1. I'm gonna try to brute force the second part as well, just to see where we're at. Because 50 million, to be honest, doesn't sound too much. So we got two nuns, which means we are not doing something right. Let's try it this way. Oh, of course, we're doing something wrong. We joined with a comma. We're supposed to join without anything, so they just get to next to each other. 71530. Let's see. 71530 940 200. Okay. Well, let's brute force. So it's not time, it's actual time. It's not record, it's actual record. So for a loop that will loop about 700 times, 70,000 times, our timing is 20 milliseconds, 71503 the result, 71503. So let's try it with the proper input, and maybe we'll need to take a coffee break. And it's going, and it's going, and it's going. And 5 seconds later, we get something. Let's see if that is the correct value. Yep. So, brute force to the rescue. It does take some time. So let's just run all the tasks so far, because one of my side goals, so to say, it is to have all of the solution in TypeScript and run together to last under a minute. But right now this one is kind of spoiling it, because there will be tasks that I won't be able to optimize too well. And I have a feeling that this is very much optimizable. But, and you can see that right now 94% of the total time is spent on the second part of task number 6. Not ideal, but not bad. I do have a feeling that there is an analytical solution to this, or maybe even a binary search solution to this, because it seems that we are looking at an interval, so to say. So we can say, well, let's assume that the interval is this, and then do some checks to see whether we are off or on the interval. So we don't need to actually run all the 50 million cycles. We can run something that is like a logarithm of that. It is optimizable, but for now, for loop goes brrrr. So keep developing. Don't forget to click on all those buttons and keep developing.